In this question, there is an external magnetic field and rigid wire is placed in this external magnetic field. We need to find the net force on this wire. So if we look at the shape of the wire, it is having two portions or maybe three portions, two straight portion and one semicircular portion. Okay, and it is having current I and magnetic field direction is given. There is a slight mistake in the actual question. The magnetic field is actually in the Z direction. Like if you look at the figure and the axis is given, so based on that we can say that magnetic field is uh, coming out of the page, which means it is in the positive Z direction. Okay, so uh, we can say that net magnetic force is due to three um, components or three parts. So two straight part, straight section, and one is semicircular section. So let's consider the straight section, maybe this one. So it is having current I, and let's consider the length is L. So here the force can be written as F equal to I L cross B. Okay. So how do we write this L vector? L vector we have to consider in the direction of current. So it will become I L, since based on this axis we can say it is in j cap direction. Okay, so it is in j cap direction and cross product with B0 K cap. So this is for this particular section. Similarly, I can calculate for the other straight section. This one, let it be, okay, let this be F1 and that is F2. So here we will get I, L. In this case, it is negative J cap since current direction is downward, and B cross K cap. So if you look at both of them, like F1 and F2, their magnitudes are same, but the direction is opposite. When we add them, it is going to become 0. So this F1 plus F2 is going to become 0. So only we left with F3, that is the semicircular portion. So net force is equal to F3, that is due to semicircular portion. Okay. So if we have a semicircular portion, something like this, whose radius is R, and let's consider current as I. So it is placed in the external magnetic field. Now we want to find the force on it. We know how to calculate for a straight wire, right? But for the semicircular portion, we can consider this as straight wire and then find the force. How do we consider this as straight wire? We just need to know the starting point and the ending point and connect both of them and draw a straight line. That should be fine. So this is I and this is going to be F, and like this is our semicircular path. So irrespective of the shape of this one, if you consider the starting point and ending point, uh, and if you know the current, then the forces are going to be equal. Of course, I'm not going to do the derivation. This is a kind of result you can like consider, and we can find the force accordingly. So here the length is going to be twice of the radius, because like this side is going to be R and here one more R, so the length is going to be 2R, and current direction is in the x-axis direction, because like here you can see like this is what I'm talking about. So current is in this direction. So let's find the force F3. So I L vector B vector. So current I, instead of L it is 2R and direction is X cap, which means I cap I have to write, and B0 K cap. So I cap cross K cap, it will be negative J cap. So I'll get 2I B R negative J cap. Yeah, fourth option is the correct answer.